Here we're being given two equations. We're being given one equation right here, y equals 2x cubed, blah, 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 and a second equation right here. And what they want to know about those is they want us to find the area enclosed by those two curves, the area between those two curves. The area between two curves is an integral setup that you just have to know when you go in to take this test. To set this problem up, to find the area between two curves, you're going to take the integral from a to b of whichever equation is on top in that space, subtracting off whichever equation is on bottom in that space. And one of the critical setups on this is to make sure when you subtract that you're subtracting the whole bottom equation. So you want to make sure you put that in parentheses. The a and the b here, the bounds, are generally going to be the intersects of those two graphs, because that's where the region that you're trying to find is going to close itself off, or it's going to bound itself at the edges. This, luckily for us, is in a calculator required section, so we can do most of this work in the calculator. The first thing that we're going to want to do right now is we're going to start off by just trying to figure out which of these equations is on top and which one is on bottom. And so to do that, I'm just going to go into my calculator. I'm going to type into y1 my first equation here. And then in y2, I would put my second equation. And from there, you're just going to go ahead and graph it. And what we're trying to do right now is we're really just trying to set up the larger integral that we're going to go find the value of. So we'll open up our calculator, we'll go to the y equals, we'll type in the first equation that they give us, minus 4x squared plus 7x plus 9, and y2, we'll put the second equation that they give us. And then from there, we're just going to graph it, and literally all we care about is which one is on top and which one is on bottom. So I'm going to graph these two equations, and what you can see here right now when you first graph it is you can't really see much. You can see that they sort of come together and intersect at the top of the screen, but we're not really looking at any region yet. So you're always going to need to be on the lookout to adjust your own window. So from here, I would adjust my window. I'm going to hit the window button at the top, and it looks like I need to move my graph up a little bit. So I don't know how far. I'm going to start off by just moving that y max up to 50, and then I go ahead and graph it. And so now I can see a little bit better what's going on here, right? So if I look in the middle of my screen, I can sort of see that I actually have two regions that are going to have areas bounded by them. And I'd probably want to zoom in a little bit more on that, so I could, if I needed to, now I can go ahead and I just hit zoom, and I can choose the number 2 option, zoom in. And then what I want to zoom in around is this little space down here. So I just kind of move my cursor into the middle where I'd like to look a little bit better at, graph it, and now I can see a lot more clearly that I have actually two regions that are being bounded by these curves. I've got this first region on the left here, which is the blue graph, is above the red graph. The blue graph is on top and the red graph is on bottom. However, they then switch positions. On this second set of areas here, I've got the red graph is on top and the blue graph is on bottom. And so what that means for us is we're actually going to have to set up two integrals in this situation and evaluate two different integrals to get out that answer. So first things first, we just graphed this so that we could see what was on top and what was on bottom. And what we discovered is we actually have two equations that we have to work with. So we'll set both of those up right now. So for the first one, the blue graph, if I go back into my y equals, I can see the blue graph was my y1 graph and the red graph is my y2 graph. So for the first integral, I need blue on top of red. So what I would be looking at now is I would say, okay, I need the integral. The blue graph is my 2x cubed graph. So this would be 2x cubed minus 4x squared plus 7x plus 9. And then we're going to subtract off, again, always in parentheses, this time the red graph, which would be 7x plus 8. That's going to be one integral. And then guess what? We're going to have to add to that a second integral where we flip-flop their position. So on the second one, we can see that our red graph here is on top of our blue graph. So we now need to put the 7x plus 8 up top minus, or again, always in parentheses, the full equation, 2x cubed minus 4x squared plus 7x plus 9. Now, step 2 of this process is we need to go find what these bounds are going to be here for both of these. And so as we saw in the graph, these are going to be our intersects. And so we're going to run through a few different times this process where we hit second, calc, and then we're going to choose that number 5 option, intersect. And that's going to find where these graphs are running into each other and where those regions begin and end. So I open up my calculator, I hit second, calc, the button above trace at the very top there, and then I go down to that number 5 option, intersect, and I hit enter. It's going to ask me a series of 3 questions every single time. The first 2 questions I could really care less about. It's going to say, is that the first curve? Yep, that's my first curve. I go ahead and hit enter. It'll switch automatically to the second curve for me and say, is that the second curve? Yep, that's the second curve. Go ahead and hit enter. It's the third question here, the guess, that we really care about. So the first time through, I would go ahead and scroll down to the left here so that my cursor is close to this first intersect. The calculator, when you guess, is just finding the intersect that you're closest to. So I want to find that one on the bottom there. I hit enter. It tells me my intersect is happening at negative 0.4516. So my lower bound right now is negative 0.4516 for that first region. So I get rid of that and I type in negative 0.45, what was that, 4516? 4516. There's my lower bound. Then I'm going to go calculate that intersect in the middle. So second calc, number 5 intersect again. First curve, hit enter. Second curve, hit enter. And again, on the guess, we're just going to scroll up now. We want to find this one in the middle. So I hit enter again. Says the word intersection, so I know I did everything right. And then that 0.5969 is going to be our intersect. The interesting thing about this one is it is the upper bound for that first region, but it is also the lower bound of the second region. So 0.5969. So we'll replace that with 0.5969, and we're going to replace this with 0.5969. And now we just need to find that last bound. So open the calculator back up, back into calc our intersect, second calc, choose that number 5 option, intersect. First curve, just hit enter. Second curve, just hit enter. And then again, on the guess now, we're just going to scroll up to the right here so we're close to that intersect at the top. Hit enter a third and final time. We get out our intersection, and that x value is what we're looking for. So 1.8546. So this now becomes 1.8546. Now that we're done with that, now we're ready to actually go calculate these 2 values for these 2 integrals here. And once we do that, then we're going to be able to just add those 2 answers and find out which of the above options is our answer. So step 3 here, what you're going to need to do is we're going to go back into our y equals, and we're going to need to we're going to have to take these down a chunk at a time. So to do that, we can actually use some cool buttons on the calculator that you'll be happy you know. It's just going to save you a bunch of typing time. So to save ourselves that typing time, what we're actually going to do is in y3 right now, we're going to put the equation. So if you think about it, this is what's in y1, and we're subtracting off what is in y2. So in y3, I would go y1 minus y2. From there, I would go ahead and graph those and do a second calc, and we're going to choose this time the number 7 option, which is the integral of f of x dx. And then the calculator is going to ask us a few questions, and we'll go from there. So we open our calculator back up. The first thing you want to do so that you don't see these other graphs is you're going to scroll so that your cursor is flashing on top of the equals. And if I just hit enter right now, it gets rid of graphing on that equation. Those equations are still there, but now I'm not going to graph them. And in y3, I now want to put y1 minus y2 because that's my top equation minus my bottom equation. To find those y's, what you do is you hit the alpha button, and then you're just going to hit the trace button up at top here. So if I hit alpha and then trace, it pulls up a menu for these y1, y2, all of my different graph options. And I want the top equation to be y1 minus my bottom equation, again, alpha, and then hit that trace button, and I want to subtract off y2. So now I'm graphing that first integral, but I didn't have to retype everything. So we graph this, and you don't really even care if you can see the graph is kind of the weird thing about it. If you wanted to, you could zoom standard or move your window around, but to do this process, you don't have to see the graph. You just need to know what your bounds are, which we have written down over on the left side here. So from there, I go through this step 4. I'm going to hit second, calc, and then choose the number 7 option. So I hit the second button, choose the calc menu, the button above trace at the very top, and then I'm going to choose this number 7 option, integral of f of x dx. I hit enter right now. And the first question it's going to ask me at the bottom of the screen is it wants my lower limit. Well, the lower limit we found was that first intersect. That's going to be negative 0.4516. Type that in, hit enter. It's then going to ask you for an upper limit. And so the upper limit is just our upper bound, which is going to be the 0.5969. I hit enter. It does its thing, and then at the bottom of the graph here, I can see integral of f of x dx equals, and here's my answer. So 0.6848 is what I'm looking at. So for this first integral, we're getting out 0.6848. Now we need to add to that the answer for this second integral. So coming over here now, these things have now switched position, right? This is where my y2 graph is, and this is now my y1 graph. And so from there, what we would do is the same process. Now just go into y3, and we'll change this up. We're going to change it so that we have y2 minus y1. And then after that, we're going to go through the same little graph, and then second, calc, and again, we're going to choose the number 7 option in that menu, integral of f of x dx, and we'll get out our second part of our answer here. So back into the y equals, keep those two graphs in there, and now I clear these out, and I need to flip-flop the position. So to get my y's, I hit alpha, and then the trace button, and it pulls up this menu. I want y2 this time is on top, minus, and then alpha up to trace, and that's going to get me my other option. So I want y1 as my bottom. So I hit enter there. Now I'm ready to graph it and do my calc, my integral. Again, I don't really care if I can see the graph in this situation. I just need it to be there. So now I hit second, calc, and I choose that number 7 option, integral of f of x dx. So it's again going to ask me for the lower limit. The lower limit on our second integral was the 0.5969. So I type that in, I hit enter. My upper limit is going to be the 1.8546. So I type that in, I hit enter. And then from there, it tells me at the bottom of the screen what I'm looking at. So my integral of f of x dx is going to equal 1.11228. So I'm looking at 1.11228. And to get our final answer, we now just need to add these two values together, and we'll be done. So I go back to the normal part of my calculator, and I just say, okay, 0.6848 plus 1.11228. I hit enter, and I get out of there 1.797. And on the AP test, they always do everything to 3 decimals. So that's going to be my final answer, and I can see that my final answer option would have been right here. So the key to this was you need to know this setup, this integral setup, the area between two curves. And then as we go through this, we use our calculator to find our bounds. We use our calculator to find out which equation's on top and which is on bottom. And then we use our calculator again to go ahead and give us our answers for our integrals. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.